Hi, I'm BrendaEM. I'm going to be working on a rather large format 3D printer, and I still have my little printer, and I've been having better luck with it, printing out stuff. Some of the prints I've been printing out have been kind of not big, but long in duration. Like I've had like a 13-hour print and an 8-hour print here, and so forth. And sometimes with those prints with an running open loop, sometimes you run into problems. And I also came up with a new design. Well, actually, what we're looking at here is the design inside Rhino 3D. And I love Rhino 3D, and I've drawn a lot of things with it, and it's very intuitive. I think it's probably has the most intuitive graphical user interface of any 3D program. So the design allows a print that is twice as big as it would be with a kind of a regular Prusa printer. So without the table moving back and forth, with this design, I'm able to get twice the Y value. So this would be 1,000 millimeters by long by about 280 millimeters high and about 400 millimeters wide. So that's pretty big. Let's hide this. And the reason I'm able to do that is because I came up with this kind of sliding gantry kind of system, in that there's a y-axis underneath the table, which allows the printer, and I didn't grab everything, but allows the printer to move this way underneath, both over and under the table. And we'll make this clear. So underneath here, I've got the y-axis, and so I'm thinking a lot of these parts will be 3D printed, like these little ends here. And it's rough doing stuff in the United States because, you know, you've got to think with, you have two systems of measurements, and it's hard to find. For instance, like this tubing here, I would have loved to be able to go to Home Depot and buy a 25 millimeter piece of aluminum tubing. Instead, it's just 1 inch. So it's hard to, you know, our supply chain, I think I'm going to get on my soapbox here. Our supply chain is so screwed up in this country. I think that the biggest problem we have with manufacturing right now isn't that Americans can't make stuff, is that we're saddled with this old SAE system, which needs to go. Anyway, so a lot of this is already made for me, and I'll be showing you the y-axis, which is almost done, oddly enough. And so I've got some aluminum tubes here, and these ends will be 3D printed with the little printer, and I believe they'll fit in there. And these will be 3D printed, and I would have liked to make these two pieces out of aluminum, but I can't afford it. You know, I was thinking of 1/8 inch aluminum or something like that with a little extrusion, and I priced it. I just can't afford it. So what I'm going to do is I was thinking about making with Lexan, because there's not that much distance between this horizontal linear rail and the vertical linear rail, so there's not that much distance. So I think I'm going to be able to get away with using sheet plastic goods, whether it's high density polyethylene or Lexan or something like that. I don't like working with acrylic because it cracks so easy if you just look at it wrong. Anyway, there'll be 2 columns which will be 3D printed, I hope. And those will be bolted from underneath onto this aluminum plate. I do have a piece of aluminum for this. I think that a piece of aluminum this thick will be too heavy for the top. And you know, and when you're designing something or making something, there's always drawbacks. I mean, if anyone comes up to you and says, well, you know, there is no drawbacks, and that's not usually the case. There's I think it was Walter Lewin who has said that there's no free lunch. And he might not have thought of it, but he did mention it, I'm pretty sure. Anyhow, so the good thing about this printer is you have a lot of y-axis movement. The downside is the higher this assembly goes with the printhead and everything, the higher this goes on the z-axis, the more this will want to tip this way. So in other words, you know, so you can only run this printer so fast. And this is an awful big piece to rotate, but let's see. So if you look in the upper right hand corner, so this high speeds would want to do this. So you can't let that happen. So you can't run it that fast. And also you want all these pieces that move on the y-axis to be light as possible, especially at the top. At the bottom, it's not so bad. I mean, this is, if you look at the, these are a representation of the linear bearing, the linear rails, and this would be the linear bearing block. And so the higher you get, you know, the further you get from, or the farther you get from these rails, the more it's going to want to tip. And it's not like it's going to break. This x-axis was made in such a way that it's not going to break. It was made to move much heavier things than this. But all it needs to do is bend a little bit, like 1/8 of a degree will make a great difference in your print up at the top. So the disadvantage for this kind of printer is that the taller your print, the less accuracy you'll have. And I'm okay with that. You know, I want to be able to print out, if I want a quadricopter prints, I want to be able to do that, or maybe a powered skateboard or something like that. Who knows? But but bearing in mind that the taller I go, the less accurate it'll be. Also, there's also a thing that the longer the print, there's more chance there is to fail, because everything is running open loop. Also, if you notice that I've got kind of an extruder and a half, and part of this I didn't draw. This came from a CAD site, and the other part, I think, which will be this motor, part of this motor here, you'll see that I've kind of amalgamated two motors, because I might use a different kind of motor. I might use a harmonic drive motor for an extruder, and I don't know if anyone's ever done that, but I certainly want to try, because they're really accurate. Anyway, I've got most of the drawing done. I have the belts, and I've got to work on this plate here as far as the drawing. I got this linear rail in. Like I said, a lot of the y-axis is already done. I use this little clear stuff as little spacers and stuff like that to show volumes. Like there's 5 millimeters between the y-axis and the bottom of this table. I kind of came up with a new, or at least a variation on a theme for these lead screw holders. And actually, this is just a texture I have in here with a little bump map. I don't want to show all these threads because it'll slow it down more. And I don't need to. Actually, this is a done deal. And actually, I've got to wait for these motors to come in to check all this. When I design something, I always make sure, just because I put specs on a piece of paper doesn't mean they're right. They could do little manufacturing changes, and I would rather not print these out without and have them be wrong. And these eventually are going to, when I print them out, they're going to be printed out in 3 sections and then bonded together somehow, probably with epoxy. And so I'm going to have to be careful to make sure that they're straight, and I've got to come up with some kind of joint and stuff. But the y-axis, getting that ready, I can do something for. And I have a bunch of bearings that I use for my x-axis, and this part's already been done and tested, and I just got to drop it in a block, and that's be ready to print, and that will bolt onto this. And so that's almost it. Actually, I've got 2 copies of stuff here. We'll get rid of the superfluous one. Sometimes you make changes. There we go. And I didn't even bother making a lot of this stuff into blocks because this is a relatively small drawing compared to what I usually make. Anyway, so we can look at. Actually, let's unlock this. We'll hide this, and I might do at some point. I might do some Rhino tutorials and stuff. Anyway, so this is the little table support. And it's weird, I know, and this is weird, and this is awful, and at least around here, locally, I know I can get 1/4-20 bolts for a lot cheaper than I can get metric ones, and that's really sad, because it's like, no, we don't want to do business overseas. We don't want to sell anything overseas, and And when I was young, my uncle used to tell me, part of the problem with owning his Triumph motorcycle is he needed special tools. Well, who wants to buy an American product if you need special tools to work on it, meaning SAE tools? Anyhow, I'm not against. I want us to do commerces. You might understand this over. If you're watching this from the other side of the pond, whichever pond it may be. But I want us to be engaged in international commerce, and we need to get the SAE measuring system is a monkey we need to get off our back. It's an addiction, and it's bad, and we're not going to win this one. And anyway, so. If you look at this part, I did not everything was radiused. If I radius this corner here, that means that this metal part will be proud and more likely to gash me. So I did radius it here. Let me fill it, and I fillet it here. Actually, I don't know. Let's see. I guess I could have done that one too. Anyhow, this is what I'm going to use for the y-axis. This was originally part of a wafer fabrication machine, and this was destined for the trash bin when, or the scrap metal bin when Terry rescued it for me, and I really appreciate that. Thank you. Oddly enough, this has really good linear ways in it. These are NHK Japanese linear ways. They're black oxided. So I think that there's actually 4 rows of bearings on them. This screw is rather coarse, so this is like a 2 centimeter or 15. It's probably 15 millimeter. Could be 20, but let's check it. So let's see. It's actually 20 millimeters. So this is a fairly coarse linear way, and I think too coarse for a CNC machine. This was a material handling way. It wasn't made for accuracy, and it was made for speed, and that's what the screw is. So I was looking at this. Well, what can you do with it? Well, the ways are good. It's still got a ball screw. So I was thinking is if it didn't have much play in it, and it doesn't, because there's like no perceivable play in this. At least with my thumb pressure. Maybe if you put 100 pounds on there would be some play, but there's some bolts here. I don't know if that's for anti-backlash. There might be 2 ball screws in this. There might not be. I don't know. But this is a good ball screw, albeit coarse. It's got a block of aluminum here. There's grease fittings here. There was an encoder on this side and a motor on this side. This is actually a block of stainless steel over here. I trimmed this off with a Sawzall in one of the in a bad afternoon, because this was not fun to trim. I should trim it again, but I'm not going to. And over here there's a coupler, and this is a 5-phase motor. I made a little mounting bracket just to see how it moves, and it was pretty good. And I think it moves enough for a 3D printer. This is going to be a slow printer, but it's going to be big. And those are probably not the combination you want for a commercial thing, but as long as I can get a few things out of it, maybe an electric skateboard base or something like that. So what I'm going to do is put a plate on here, like this ruler would be. And so this plate will move like this. And then I'll have, these won't be them, but there'll be 2 risers here. And then the axis will go over here, the x-axis will go here. This will be the y, and the z's over here. This printer needs a totally supported bed, so I cut these pieces of metal for the bed. So, and this is well strong enough to move this and some posts, 2 Z motors and an X motor and an extruder. I mean, this was made to lift probably 50 or 100 pounds, so I should have no problem doing that. And so I don't have any replacement parts for this, so I hope to take care of it and give it a long life. And these are to support the bed. Looking at this, you probably can't see in the video, but you might see some white stuff here. And this is solid Teflon grease, and this is, I think it's like $100 a tube. And it was kind of neat when I was looking on this thing. I've already worked on it. I've been working on this and simplifying it. Like I said, I cut this piece off, and there were more limit switches than I really need. I only need 1 limit switch for a 3D printer, and that'll be right there. It just clicks. I even have it adjusted a little bit. I don't want to run this too close, but that is probably as close as I want it. And this is heavy. It's got a lot of mass. The screw is unnecessarily heavy. This block is unnecessarily heavy. But because the screws course well, what else would I do with it? And I hate to see this go to waste. This plate here is 1 centimeter thick. And I already took a saw and I cut this edge off to make it more manageable. It was extra wide. It didn't need to be. This will actually mount vertically to move I believe, wafers into an oven. I'm sorry about the noise in the background. So this is the Chinese linear rail I got. This was about $50 US. It's about 500 millimeters long. I believe it's 25 millimeters between centers on this, and I haven't got these measurements in my head right now. The surface finish looks pretty good. I mean, it's a little bit coarser on the ends here where it doesn't matter. And even on this, it's a little coarser than it is on the groove or this face. This face is really done nice. The bearings themselves, they move nice. And I wish more American companies would take on the challenge of making these. They have little rubber wipers on the end. The bearings, I think, proportionally could be a little bit bigger. I mean, this would probably be better for fine things, but this would not be good for a dusty environment. Like, proportionally, I think this is a THK linear bearing, and this is also 12 millimeter as far as its rail is concerned, and these are very similar. These I think have bigger bearings, or at least bigger bearings proportionally. These are old and take out of machines. So these are going to be mounted vertically. I've got some of these that are clean. This is just a tester. And usually when I get these things, just put a little piece, take a piece of string or wire and just tie it around the end. You can't use tape because tape will slide off. But just do yourself a favor. Some of these things can be taken off without dropping all the ball bearings everywhere. Others can't. And these aren't that bad to reload. I've cleaned these and reloaded these. I have some others at the bearings that I'm going to have to make a tool for. Actually, if you look at the surface finish on this in the back, I think, to my eye, the surface finish on the back of this is finer than it is on this, even the grinding wheel. The front, so not so much. I think both of them took advantage as far as the front, but that's non-critical. Like these faces are critical. On this groove is critical. On this groove is critical. You might be able to see there's a little bit of profile difference. These have just a V notch, and these have kind of an asymmetrical kind of trapezoid. So these don't have the THK ones don't have wipers. So I don't know. It is. I'm pretty happy with this, and like I said, I wish, like in the United States, I wish more companies would take on the challenge of making these. And I don't know how many other are. I think that I feel that what the Chinese are doing is consumerizing industrial equipment, and I guess it's working out for them. I have some 1" by 1" box aluminum here. I took a little machinist scribe, and I scribed the line where I want to cut, and I had put magic marker over it so I can see it, so you can see this pretty well. I've got it clamped down in this little miter box, which I found this too on the side of the road, and I clamped it over the miter box so I don't bend it. I imagine you could kink this, and to cut it I'm going to use a hacksaw. Well, it's actually, oddly enough, I found this too. This was a great find. Somebody just threw this out, a hacksaw, or put it on the side of the road. We kind of do free cycling here, and I'm always appreciative of tools. Down here we have a power hacksaw by where my foot is. Let's see if I can get in frame here. Yeah, down there's a power hacksaw, but I'm hoping that this won't be too bad to cut. And what I really want I want this square so it looks nice. It's kind of an aesthetic thing, but I only get one chance to do this. And I measured this not twice but 3 times, and I lined it up with the other part of what I'm working on, just to have a sanity check as far as its measurement. The going's not going to be fun either way, but we'll give it a shot. care if I saw this box in half. There we go. So it worked better with clamps and the newer blade. And I left a little bit. You know, I always, you know, you have to choose. Either you can saw right on the line if it doesn't matter what you're making. But I left just a hair, maybe 1/100 of an inch or maybe about 1/3 of a millimeter, just so I can sand the end if I want to. I checked the pieces for length, and I'm right at the edge of my measurements, so I don't want to use a power sander. So I'm just going to give them a light file. Doesn't have to be perfect because you won't see this. And then I'm using a little twirly deburr, or rotary deburring tool. Anyhow, the twirly deburr to take the sharp edge off of it. You can go around the outside if you're careful. If you get it from both ends, like so, go that way, then go that way, just to keep you from getting cut. Or keep me from getting cut, anyhow. I dropped this. It's a little. Take that off. Go around the inside. And your thumb. Unfortunately, I find that because I use my thumb so much for working with tools, it's really hard for me to use a cell phone for texting, unless there's a physical keyboard. Printed out some templates and 1:1 scale. If you're going to print out templates from a printer, just make sure that you print the right size. If you don't have a CAD program, you might be able to use like Inkscape for 2-dimensional drawings and FreeCAD 3D or Blender for 3-dimensional drawings. You also might be able to get like demo or trialware of certain programs. Anyway, I find that this helps because it's less error prone as long as they're done to scale. And once again, I use my fingertip and I push the center punch to the edge of my fingertip and then line up the tip and then roll it up like this using that kind of motion. This is pretty loud for me. I'm a musician. I don't like this kind of thing. Yeah, so that's fairly, I like that because it's fairly accurate. And so I'm going to drill out these and maybe, I don't know if I'll do both sides or try to drill through. Maybe I'll drill both sides. I think that'll be more accurate. I don't know how accurate my drill press is. Sorry about the missing background, but this is Silicon Valley, and I'm lucky to have a garage space at all. There's a missing fill plate in here, and if I drilled it, it would tend to want to go through the hole. And for that reason, I'm going to use a little piece of wood to back it up. And I always try to be careful of what might happen, and for that reason, I'm using safety glasses. And when I drill holes, I tend to try to do a fairly small pilot hole and then some intermediate ones. Generally, once you start a hole, it's very hard to change where the hole is. So if you get it right the first time, it should be okay. I have to be especially careful because I'm videoing and it divides my attention. And I've got a little scrap thing here to catch some of the shavings. And I also checked to make sure that I had, it's not such a big deal on the little ones, but on the big ones I made sure that I had punched the correct sides on both ends to avoid unpleasantness. For the longer pieces, I'm using this little contraption I made. It's basically a jack, and this is made out of all thread, and this is spare parts from my 3D printer, and you can see that that the nut here is actually brass. And so right here I've got a threaded insert, and if you don't have something like this, you could use like a coupling nut, and you can usually get those even at Home Depot. But this makes it good because you could take the workpiece and support it, which is very important because you don't want this thing to go non-linear on you. And this is going to be kind of hard with the camera, but I try to let the drill bit find a hole, and if it can't, I'll hit it again with the punch. Like so. I've got the larger drill bit mounted in the drill, and actually I don't have the safety slip engaged. There's 3 areas ground on this so it doesn't spin in the chuck. And we always have to be careful of, like, if this thing stops the drill press, which way is it going to go? Fortunately, this might be long enough. The drill press actually might stop it. But if this were thicker tubing, or if it was a stronger drill press, or both, or if you're just not sure, it'd be better to clamp down the workpiece. And it's always better not to get hurt. And if this spun around like this, then the drill bit, especially if it's thin, could break. And this is why you want to make sure you're wearing safety glasses. And when you drill, it throws chips everywhere. So you have to be careful. And the last thing I could do right now is deburr the pieces using a cordless drill with a countersink. And just give it a little bit. Doesn't have to be, you don't want to go too much. Just to take the sharp edge off. Unfortunately, the eBay seller who sold me these motors shipped the wrong ones. These are supposed to be 400 millimeters long. They're only 300 millimeters. And these are just stepper motors with an included a threaded lead screw with multi-start nuts. And I wanted 400 millimeters because the Z-axis is going to be about that big. And in order for it to have, say, 300 millimeters of build height, then I'll need 400 millimeters. So hopefully I got this straightened out. Until then, this is going to be it for this video. Thanks for watching.